My future career is called Engineering in Computational Technology, and I want to study it because I have always been really interested on technology and everything that has to do with computers and new technological advancements. As well, I want to study it because through my life I have always been really impressed of how technology is advancing at a very accelerated rate, and as time passes, our smart devices can do even more and more things for us and facilitate more our lives. Integral calculus has several applications on my career. Some of them are hardware, which means mostly the energy on circuits, data management, and in this case, development of software. In this project, we will be talking about software compilers, and a software compiler is a program that is kind of a translator that helps engineers to transform a whole code made up of a specific language, such as Python, C++, Java, into another whole different language. This is the problem that was given. A compiler is a software that converts a specific language of code to another. A compiler used in programming makes such transformation at a velocity given by the function velocity respects to time equals 10t cubic root of 2 minus t squared, where the function is the conversion of velocity given in lines per second and t is time, which is the amount of lines transformed when the first second has passed. In order to solve my problem, I need to get the area below the curve, and to do this I need to first of all graph my function, and for this we will be using the application Desmos. Here I have my function, here I have my limits, which are 1 and 0, and over here I have my function already graphed. As we can see, the shaded part is the area that I'm caring of, which is between the intervals 0 and 1, and as we can see, the area is on the positive side, which means that I will not need to divide my integral by parts or to use a negative sign at the beginning of the integral. So after knowing this, let's go to solve the integral. Now we will integrate our equation. First of all, we need to get our u and our du. Our u is 2 minus 2 squared and our du is negative 2t dt. Now we need to balance our equation. In order to do this, we need to divide 10 divided by negative 5, and in the outside we need to multiply everything by negative 5. Then we just need to integrate normally, which means that we need to add 1 to our exponent, which in this case is 1/3, and after adding 1 we got 4/3. Then we needed to divide everything by 4/3, which got us to negative 15/4, and our final equation got like this, and at the end we just needed to add the constant. Now that we have our integrated formula, we can proceed to the final step. The final step is to evaluate both values in our integrated formula. Our first value was 1, and after substituting 1 in the formula, I got negative 3.75 plus c. When I did the same with the second value, which was 0, I got negative 9.44 plus c. Lastly, we only needed to add these numbers, which were negative 3.75 plus 9.44, and as we can see, the c's were cancelled. We were only left with 5.69, which means that our final result is 5.69 lines of code.